Today's problem is split array subsequences, difficulty medium. Let's see, given a sorted integer array and an integer k, determine if it is possible to split the array into one or more consecutive subsequences such that each subsequence consists of consecutive integers, meaning each number is exactly one greater than the previous, and that every subsequence has a length of at least k. Return true if such a split is possible, otherwise return false. Okay. So, subsequence, meaning like 2, 3, 4, 5, those are subsequences. They don't have to be consecutive in the array. They have, I'm sorry, is that right? Yeah, I mean, they don't have to be contiguous in the array. I mean, one has to follow the other, but not necessarily in sequence. So we could do the first two, the first three, that's a subsequence. The second two, the second three, that's a subsequence. All right. This one is true. We can do it. This one obviously is false. The array size is between 1 and 10 to the 5th, 100,000 inclusive. Each integer in the array is also between 1 and 100,000. K is between 1 and the size of the array. Complexities n log n, which means we're doing some sort of sorting or ordering here. Auxiliary space O of n. Amazon and Google like to ask this question, and topic tags, priority queue, heap. Okay, well, that's a good hint. So priority queue, we have to give this a little bit of thought. I mean, since the input is already sorted, what can we do with a priority queue that's really going to help us? Let me scoot this over a little bit. All right. What we're going to do, well, actually, see, now we can't see the input. That's all right, I can fix it. What we're going to do is we are going to put things into a priority queue, a min heap, where the elements in the heap will be in descending order. But we're not just going to put the numbers in there. Again, that's not really going to help us because they're already sorted, but we're going to put a 2-element integer array in there, and the second element in the array, well, the first element in the array will be, I'm sorry, in the array will be the number from the input array. The second number will be what we could call the consecutive count. So like what does this number represent in terms of a consecutive sequence? So is it the first number in a consecutive sequence? Is it the second, the third, etc.? So I don't know. I think that'll be more clear if we do an example. All right. So what we want in the min heap is we want, now the first number is the number from the integer from the input array. We want those in descending sequence, but if they're equal, we want the consecutive count also in descending sequence. Okay. Now there are multiple possibilities. Again, I think this will be clearer when we go through an example. But we've got a while loop. We don't have a for loop because we may have to send a number through this loop more than one time. It's a while loop. One possibility is that the heap is empty. If the heap is empty, we're going to take the integer, current integer, and just push it on the heap with a consecutive count of 1. Okay. Now, if the heap is not empty, what we do depends on the number on the top of the heap. Well, it depends on the current number that we're processing and the number at the top of the heap. If they are equal, just push the number on the heap. I shouldn't say push. Add the number to the heap with a consecutive count of 1. If the current integer is 1 greater than the number on the top of the heap, then we take that number off and we add the new number, increasing the consecutive count. For example, if at the top of the heap we have the integer 1 and a consecutive count of 1 and we get a 2, we can take the 1 the 1 off and add 2 and go to the next number. If the number can't be less than the top number, so the else here covers when the number is not equal and not 1 greater than the top. We have a non-consecutive element here. So what that means is whatever is on the top of the stack, we can't extend that sequence anymore because we now have a non-consecutive integer. So the sequential count, the consecutive count at the top of the heap, it had better be at least k. And if it isn't, then we can't create subsequences of at least k. If it is k or greater than k, then we'll just take it off. We have a sequence, and we'll go back to the top with the same number. Okay. At the end, we will look at what we have in the heap and make sure that all the consecutive counts are at least k. All right. Let's try an example here. Move that over. Yeah, I think we can see anything. We'll use the first example here. Let's see. All right, so we have the priority queue. We have I, which equals 0. I don't think we need to keep, well, we don't really need to keep track of I, but, okay, I is greater than array length. Min heap, let me get a pen here. All right, I'm going to keep track of the heap over here. All right, so we'll process the first number, and that is a 2. So we go in here, is the heap empty? Well, at this point, the heap is empty. So we're going to add to the heap the number and a consecutive count of 1. So let me put that here. That is a 2 and 1. Okay, and then go to the next number. Next number, maybe I should tick it off down here, is a 2. So we'll go down here. Top is min heap peak. You can see what's on top of the heap there. Array of I equals top is 0. It does equal that, actually. So min heap, add the new number and a consecutive count of 1. So those are actually going to be the same. We have another 2 and another consecutive count of 1. Okay. Go to the next number. Next number is 3. All right, so we go through, is 3 equal to 2? No. Is 3 equal to 2 plus 1? Yes. In that case, take the top number off, or the top array off, and add to the heap the new number 3 and the sequential count plus 1. So this is what we're going to pop off of there. And we're going to add 3 and increment this count 2. So that is going to go in the heap here. 3, yeah, that's fine. 3 and 2. Okay, and we will pop this. Okay, next number. Next number is also a 3. Compared to the number at the top of the heap, it is not equal. It is equal to top plus 1, so we're going to do the same thing. Take the array off the top of the heap and add a new array, new number, and increment the consecutive count. So we're going to have another element on the heap here. 3, 2. Okay. And let's see. This has to come off. All right. Running out of space here. Okay, next number. Next number, 4. 4 is not equal to 3. 4 is equal to 3 plus 1, so we can add, let's see, take the first off and add 4 and increment the count. So what we're going to have is 4 and 3. Okay, and the 3 and 2, these are going to come off. All right. Next number. Next number is 5. Is 5 equal to 3? No. Is 5 equal to 3 plus 1? No. Else. Now we're in the else. If the consecutive count on top is less than k, and k in this case is 2, it's not less than k. If it were less than k, see, we've got a problem because now there's no way to extend that sequence. So we can just take it off because it is a subsequence of at least length k. So let's take it off. All right. Now there's nothing here as far as incrementing I. It's just we're just going back to the top of the loop. The heap is not empty. Is array equal to, is 5 equal to 4? No. Is 5 equal to 4 plus 1? Yes. Let's see. So we take off the, well, we pull up, we take the array from the top of the heap. We add a new element to the heap. I don't want to take it off before I add the new one, but I have no place to put it. So I'm going to put it right here. 5, we're going to add the 5 and we're going to increment the consecutive count. 4. All right. Now we'll take the number off the top of the heap here. Okay, and we would increment I. At that point, I is going to be greater than the array dot length, and we're done, except for one thing, and that is, can I scoot this up? Actually, I can turn that off now, and we'll go here, and we'll scroll this up a little bit. All right, all we have to do now is go through the heap. For each element in the heap, make sure that the consecutive count has a length of at least k, which it does. There's only one element on the heap, and it has a length of 4. So the answer is actually a little bit, I mean, what we come up with here is actually a little bit different than this 2, 3, 2, 3, 4, 5. I mean, what we came up with was 2, 3, and then 2, 3, 4, 5. So we had 2 sequences, but they're both of at least k. So that is it. So yeah, again, go through the iterate through the array. If we have an element that is equal to the top number on the heap, just push it, count of 1. If it's consecutive to the top number of the heap, remove an element from the heap, put the new element on, increment the consecutive count. If it's not consecutive, then we got to make sure that the element at the top of the heap has a consecutive count of at least k, because we can't extend that any further. We have a non-consecutive number. And then at the end, make sure that any remaining subsequences in the heap have a length of at least k. And if that is the case, then we can return true. All right, let's get rid of these, and I'm going to submit this. All right. Go ahead and like the video. What else? You can subscribe to the channel. It's free. And that's it. We'll see you next time.